Alright, what's up everyone? In this video, we're going to be going over Unit 7, Lesson 9, which is partitioning a directed line segment. So, partitioning is just a fancy word for saying we're dividing something into parts. So in this lesson, what's going to happen is we're going to be different segments, or given different segments. So you might be given a coordinate grid where you can plot the segments, or you might just be given the points. But essentially what's happening here is we are going to be looking along different segments and trying to find points on the segment that divide it into a certain ratio. So for example, let's say, I don't know, you could find a point anywhere along the segment, like let's say this point right here, and we can see like, hey, if the segment was divided up into a bunch of parts, maybe we want to say, hey, this is a 5-to-1 ratio at this point P, right? So the ratio is going to differ depending on the question. But a directed line segment is just a line segment where order matters. So typically we say, hey, you can call this segment A, B, or BA. But with a directed line segment, it has a very specific starting point. So for a directed line segment, BA would not be an acceptable name because that would assume that B is the start point. So just be mindful of that. Whatever the question lists the coordinates in, you take the coordinate that they list first, and that is going to be your start point. So some general advice. In all of these questions, we're looking for a specific point, so we're going to deal with the x and y coordinates separately, similar to how we talked about midpoint. And if we don't have a coordinate grid for the question, you should try to sketch it. So on your Regents exam or on a test, you guys can look for any coordinate grid anywhere on the test except if it's for a short response question. So if there's a multiple choice question with a grid, you can use that grid for whatever question you want, because sometimes a sketch can help you assess whether your answer is correct or not. We'll talk about the other advice in a little bit, but let's just get into an example to try to make sense of what this topic is actually doing. So it says find the coordinates of segment AB, find the coordinates of point P. Usually it's denoted by point P. Along the directed line segment AB with A at -2, 7, and B 3, 2. And it wants the ratio of AP to PB to be 3-2. So this ratio is super important. Now, the first thing that we want to figure out is what is our start point. Well, our start point is A. They list A first, so this is going to be like our home base when we're finding a bunch of numbers and using formulas. We're going to use A to get us started. So we first want to figure out how many total parts is the line being broken into. So if the ratio is 3-2, what that means is that there are 5 total parts. Now we get that just by adding these two numbers up. So whatever this ratio is, if you add these up, you will figure out how many total parts you have. Now that's important because if the ratio is 3-2, we want to figure out how much are we actually traveling. Because if we're traveling the entire way from point A, we're going to end up all the way at point B. But we don't want to end up all the way at point B. We're trying to find a very specific location for this point. So if the ratio is 3-2, we take that first number and we divide it by the total parts. So that means we are going 3/5 of the total distance. And we want to go 3/5 of that total distance so that we can split this segment up like the question wants. So just thinking about this conceptually for a minute, when we travel along the coordinate grid, we have to travel in the y direction, which is going up and down, right? But then we need to also travel in the x direction, which is going left and right. So a big concept is figuring out going from A to B, right? You want to figure out how much am I traveling in the y direction, which is delta y. And how much am I traveling in the x direction, which is going to be delta x. So let's actually figure that out right now. So delta y, again, is going to be how much you are traveling in the y direction to get from your start point to your end point. So to get from our start point to our end point, which is down here, I need to go down 1, 2, 3, 4, 5. So my delta y, since I'm going down 5, it's going to be -5. So to get from A to B, I need to travel down 5 in the y direction. And for delta x, how much do I need to go over in my x direction, I need to move to the right 1, 2, 3, 4, 5. So since I'm moving to the right, that's going to be positive 5. Now this is huge because to go the full way, I need to go down 5 and I need to move to the right 5. But we don't want to go the full way. We only want to go 3/5 of that way. So let's first find our y coordinate. So our y coordinate of our point, we're going to take our original y value, which in this case is 7. That's where we're starting, right? We're starting at the y value of 7. But I know I need to move, to get from B to B, I need to move down 5 units, but I only want to move 3/5 of the full length. So we're going to add 3/5, and we're going to multiply that by our total direction, or our total distance that we need to go in the y direction. So if we simplify this, we're going to get 7 plus 3/5 of negative 5, which is going to be negative 3. And if we simplify that, we will get 4. So I know the y coordinate of my point is going to be 4. Now let's find the x coordinate. So the x coordinate is denoted by p of x, right? So we start with our original x value, which we're starting at negative 2. Again, we're doing that with our start point here, is negative 2. And then again, to go the full x direction, to get from A to B, I need to move to the right 5. But I don't want to move the full direction. I only want to go 3/5 of that way. So I'm going to go 3/5 of 5. And if we simplify that, we get negative 2 plus 3, which is going to give us positive 1. So our x coordinate is 1, which means that our entire point P, we take the x coordinate and the y coordinate, is 1, 4. Now let's go ahead and plot that to see if it makes sense. So P would be about here. That looks about right. This would be 3, and this would be 2. So if you divided this up, there would be 3 parts here and just 2 parts to the right of P. Now, this is great when you have a grid, but we kind of got to figure out how to generalize this. So these are some general formulas that we can use to help us find the x coordinates and y coordinates of our points. So you want to make sure you know what each variable stands for. So this here would be the x coordinate of point P. Obviously, this would be the y coordinate. And then x1 and y1 have to come from your start points. So these are the x and y coordinates from the start point. Now remember, the start point is whatever point that they list first for you. And then this ratio part of the formula here is figuring out what fraction of the total distance are we actually traveling. So I believe in the example before, we were going 3/5 of the way, right? So depending on the question, maybe you're going 2/5 of the way or 4/6 of the way, right? It could be any a fraction there. So what fraction of the total distance are we going? And then delta y and delta x are just figuring out like how much does my x value need to change to get from my start point to my end point. Now I'm going to just put an arrow over here for the y coordinate. So how does my x value or y value? And you can do this a couple of different ways. So you guys already have exposure to delta y and delta x. If you think about the slope formula, right? I kind of introduced to you guys that slope is delta y over delta x. Or delta y, right, is just your amount of rise over your amount of run. So you guys already know how to calculate these things. So delta y, right, rise over run. Another way that we see this formula is y2 minus y1, right, over x2 minus x1. So you can even go further and deduce it to that, right? And if you wanted to write, instead of writing, so delta x is this denominator here, right? So this part, x2 minus x1, is your delta x. That's how much your x value is changing to get from one point to the next. And then delta y is the same idea of doing y2 minus y1. Now remember, we already have y1 and x1 accounted for. These must come from our start points. They must. And then x2 and y2 can come from your endpoints. All right, so make sure you guys have this or these labels filled in for your formulas, and we'll be working on a bunch of questions. And just remember, if there is no coordinate grid given to you, it really, really might help sketching, because sometimes when you don't have a grid, it's really hard to kind of just plug and play into formulas. Seeing it on a sketch kind of helps you visualize what's actually happening.